Hey, welcome to another CTO Dose. On the other line, we finally combined two different worlds. And Ellis, founder of OpenFaaS, CNCF Ambassador, came to me and said, Keith, you know what? I want to do a CTO Dose on BareMetal and cloud native. Those things seem not to go together. I'm building the CTO Advisor hybrid infrastructure, and it's a bunch of BareMetal servers. You guys have seen my adventure about that, and we'll talk a little bit about that. But I've kind of thought about that as the legacy portion of the data center, not necessarily doing cloud native, maybe running Kubernetes on that BareMetal infrastructure, but not using cloud native concepts, interesting ideas or concepts around it. Alex, welcome to the program. Like, give me the overview. What are you talking about here, man?
Yeah, thanks for having me on. It's always great to sort of speak to my friends, and I know that you have this pedigree of servers. All of your tech field day events that you've done with Stephen Foskett going all the way back, sort of this band of server huggers. And I've spent the defining part of my career trying to convince people that they shouldn't be thinking about servers. They should be thinking about serverless, focusing on the code. And so over the last sort of month or two, I've been really digging into BareMetal. What are the concepts? How does it work? And then thinking about, well, can we apply that to cloud native? Is it relevant? And that sort of culminated in a couple of things. First is, I asked a question on Twitter, what are your favorite tools and processes? And founders of different projects like Digital Rebar, Packet's Tinkerbell project, Plunder from Dan at VMware, they all commented back with their projects, and some people with what they were using at work. And I compiled it together in a repo called Awesome BareMetal. And this is a really curated repo. There's no junk in it. You can't just put anything in. It's got to be relevant. It's got to be used and open source.
So let's talk about the response. What was the response? Because your audience is very, very, very much on the cloud native side. Mine's is in the physical server side, and there's some overlap, but not a ton. What was the response?
The response was surprising. It was kind of like tapping into something, like a seam of like coal, like in a mine. It's like I've tapped into a seam and it goes down deep. And it turned out that a lot of the people that I was speaking to had past lives of managing servers and net booting them and doing storage, or working for companies like, who is it that makes SolidFire? NetApp, right? And so people that have kind of been working with all that kind of equipment and kit that are now like, well, we've been told it's all about Kubernetes now, and they're pivoting, and that's their role, is learning, talking about and using Kubernetes. But they've got this history, right? And that's what I tapped into. And so there's endless replies on the thread. There's some debate. I mean, there's dozens and dozens of replies in here. I had to turn my notifications off in the end. My phone just kept going. And it's very rare that I'll get something like that. Like, I'll tweet about Golang, and there's something about Golang right now that's very popular. There'll be 200 likes about a Golang book, but no comments, right? This had a similar amount of likes, but then there's just so many comments. And what I did is I looked at all the projects. Some of them I already knew, and I did like a BS test on them and then put them into this repo. Then spent a bit of time with a few of them, and going back to my history, like 20 years ago, I was in school lab and I was helping the network admin staff. That's how much I loved computers back then. And I would go and install Windows and restore computers. Now, sometimes that would mean taking a CD or floppy disk drives and putting it in the machine, but that actually didn't scale well. And other times it would mean using something like Norton Ghost or an imaging software, but we'd have to network boot the machine. So we'd have to boot the machine off the network. And then you get into all of these different technologies, and actually they've not changed in 20 years.
No, they haven't.
I actually have a picture here that I'll share on my screen, and this is what I put together. And what you see is pretty much what you get with BareMetal. The first thing that happens is there's an unprovisioned server or or Raspberry Pi, let's say, and it starts off life by saying, I want an IP address. And that comes from firmware that is in the network card, right? And this is sort of hard coded in. This whole process is called PXE or PXE. And there's a newer generation of PXE called iPXE that will allow you to boot over the internet, right? But this version, the first thing that happens is I want an IP, a DHCP server will give you an IP, and then it will say, probably say, oh, by the way, I've got this TFTP server, and you can go and download some more firmware from there, and then you can boot off that. And so the computer will go there, and first of all, it will send its MAC address as a URL. And if it doesn't meet anything there, it might go to the root level and see if there's anything there. And then it will download the file it's told, run that code, and let's say we want to run an operating system over the network, right? It will then mount an NFS, potentially a network file system, and boot up Linux, right? So we've gone from...
It's pretty funny that you describe this process, because this process is the same process I used, oh man, I'm dating myself, almost 30 years ago to boot Windows 3.1.1 from the network onto desktops. So right. Nothing in that sense has changed, except for I think when we apply it to take it from that PC world, and even in the network space, we very much still use this process to configure network devices, because they're all pretty static. I have 1,000 nodes of network devices, 800 of them are the same thing over and over again. But in the data center, you run into these problems that I ran into when I built the CTO Advisor data center over this past weekend, which was, I went to do a simple thing of connecting a monitor to my to one of the used Dell 730Ds, XDs that I bought. And the monitor was VGA. I mean, the monitor was a modern monitor. It had it was basically, let's say it's a Thunderbolt monitor, and the server was a VGA server. Literally, there was no way to get VGA to Thunderbolt. I'd have to retroactively go back and get a old monitor to see the screen. So simple problems like that happen over the course of maintaining servers. So there's a couple of things I wanted to ask you about in your research. One, this basic process which you identified, and it'd be great if you can just show this to us. And then two, this next level of complexity, which is kind of day two management, as the data center starts to morph, what practices can we put into place to kind of manage that generational craft?
Well, I hope we got enough time for this, but basically, you're right. There's two parts to this. One is I've got a computer, it's potentially got no storage or unprovisioned storage, and I want to get an OS on it, but that isn't the whole story, right? And that's where these cloud native tools sort of come into play. Can you see this? I can't really see.
It looks like let me
Raspberry Pi.
Raspberry Pi, yeah.
It's got 4 gigs of RAM, and it's not actually got an SD card in it. You can't see that. And the SD card is here. Okay, so take my word for it. Now, why do we not want SD cards in Raspberry Pis in production? Well, they've got a limited wear cycle, and once you approach that, the file system basically goes really bad. It will go read only. Yep. You can't use your computer anymore. And actually, talking about HDMI, there's pretty much no adapter that you're going to get off the shelf or in a supermarket or in a store to fit into this. Actually had to buy something specific. This is a micro HDMI. It's absolutely tiny. It looks like micro USB. Same problem, but not to matter. I've got an Ethernet cable, plugging it in, and then I've got a server here. And this server is pretty much exactly like this one here. It's got some network storage using NFS. And what you can see is rather than a DHCP, I've actually gone for the serial number because the Raspberry Pi is a little bit non-standard. And every device is enrolled with a serial number. And if we look, so I don't know which one I've got in my hand. Cannot find. Right. Which ones have we got? So let's look at that one, C3. If we look inside, this is a Linux operating system, at the host name is a serial number. So it's pretty cool, actually. I can categorize and manage all my computers just with the serial number, because it will advertise this, it knows it, it's unique, and it's a great way of sort of managing Raspberry Pis. If you're using PCs and servers, you can use a DHCP address instead, right?
Right.
So I know what we'll want to see. I want to see this cable in there and see what happens. Well, I want the logs of the DHCP server and TFTP server. So I'm going to get them up using systemctl. And this is going to go in here. We'll get the fans. Fans are spinning up. We've got a couple of lights on there. And I actually think it's slightly faster booting this way than on the SD card.
I would assume that is the I/O of a Raspberry Pi is fairly slow.
This is what we're looking for. We've got basically what's called like an advertisement or request that's come in. And this computer's got 2 network cards, so that it's got a separate subnet of .2. It's a private subnet. And we can see that it gave an IP address out of a 114. We'll copy this. It then gave it some other data, like its router address. And here's an interesting bit for me, which is, first of all, we're trying to get different files according to the serial number, right? And then it also looks at it from the root if it doesn't find it at the serial number. And this is how I can basically provision or enroll hundreds of computers, if you like, and have them all have their own different boot file, have them all have their different NFS mounts. And then once it's up and running, it's basically just going to provide DNS for it. So that was the whole thing. We went from here, we asked for an IP, we got one, we saw the logs for that. It then gave a boot file, and this is the firmware in the Raspberry Pi. It gave the command line, which is what the kernel uses to boot up. And we can SSH into this now. There we are. Now the
that storage. So when you do a list for the storage, that storage is NFS running on a remote box.
Yeah. So if we do an LS bulk, what that will show us is there's one disk, which is actually a USB disk that I'm using for something else. Mm-hmm. So it doesn't actually have a SD card on it. And we look at mount. Let's see, look at the mount, and what we'll see on here is that it's a bit confusing to look at all of this, but that's the bit we want. It's my server. So the root file system is mounted over the server, and a good way of seeing that is in etc fs tab, and it's just a mount for it in there.
And what version of Raspberry Pi are you using in this project? Yeah,
this is Raspberry Pi 4. It's got 4 gigs of RAM. We can see that if we do 3-H. We've only used 80 megs, right? We've got loads of space. We could install Kubernetes on here. We could have a lot of fun with it. Or we could actually get 4 of them up at once and have a little cluster going. The other thing that I've done here is, unfortunately, as I describe in the article, NFS and containers, they're just not friends. No. There's no way of really getting them to work together. So I thought, well, what can I do about that? The first thing I did is I looked at iSCSI instead of NFS. And iSCSI is actually great. It works out of the box. There's no fiddling about, but it's really complicated to set up and maintain. In fact, you're better off buying a NAS than running it in software. But I have it working. The other thing that you can do is you can actually just have some ephemeral storage and say, well, you know, this USB drive is sacrificial. It's going to run the containers. The OS is going to run on the network. And when that dies, I'm going to pull it out, put another one in. And there's actually a script on here that will re-provision the USB when it boots up again.
So let's talk about, we got the basic concept there. I really love that you used a Raspberry Pi for this. I have to go back and check my notes, but I'm almost certain that Raspberry Pi version 4 separated the I/O from the USB and networking, so there's dedicated network I/O, which
Yeah.
which would explain why booting from network is faster than booting from the local disk. That makes perfect sense, which also means that when we scale this up to kind of a data center class solution, that this makes for some, I'm starting to see your point with bringing cloud native concepts to the data center. If I scale this up and I just put a bunch of white boxes or a bunch of Dell, really doesn't matter. Your article kind of goes into a concept about the tools, the out-of-bound management tools that some of the providers have. But just thinking to this open concept, I can now provision Kubernetes nodes out of nothing, out of a white box that was nothing before, or something else before. Are there tools that enable to do that in a cloud native function?
Right. And that, that's really what we get to. I've showed you very simply going from nothing, from a white box, a black one, if you like, to running an OS. The next step was to install Kubernetes, but there's more to it than that. Suddenly, we need to catalog the inventory. Now, it's great for me because I'm able to plug the Raspberry Pi in and it tells me its serial number. But that might not be enough. It doesn't feel very secure to just let devices be plugged in and I provision them with secure code and credentials. It'd be better if I could gather all of the data, the MAC addresses, that I could perhaps give them a certificate ahead of time, a client certificate, and then trust it so that when they're turned on, they're already in my inventory. I know to trust them. I can give them the firmware. I can provision them. Maybe I have a set of images, an image store that says, right, this is Ubuntu, this is CentOS, this is Docker, and this is a Kubernetes worker. And then the next
that's
bit,
exactly how we manage management cards in the data center. We provision certificates to them so that when the data center ops are connecting to it, they know that the server that they're connecting to is an authenticated server on the network. No one can just take, another Dell 730 XD that's been compromised, put it on the network, and then, so now when I get a certificate warning, I can trust that it's a warning and I should not provision this server.
Yeah, so IPAM, not IPAM. IPAM is IP address management. What we're talking about is, and I never quite get this right the first time, IPMI, basically Intelligent Platform Management Interface, IPMI.
Mm-hmm.
And it turns out that that's one standard, but there's other standards as well. And when I was in the lab 20 years ago, it wasn't actually this technology we used. We used Wake on LAN, which predates it. The Wake on LAN is kind of like very, very early days. Just, I'll send you a special network packet and you turn yourself back on, or if you're suspended, you come up. This one is pretty awesome. The first time I used it was with an Ampere server. The guys over there, they sent me a server like this big. The photo is in this actually. It took a family-sized dining table just to plug it in, much like your ones. I don't have a rack. I don't even have anywhere to put it. And it's super noisy. But it comes with this. And so I downloaded a Java client, I connected over the network, and then I mounted an ISO from my computer to it, and I installed Ubuntu. And that whole experience was like something I'd never done before, and immediately saw that value in that out-of-band console and management. Right?
Yeah, we live and die by it in the data center. There used to be a time where we would have a KVM keyboard video mouse adapter with, the fancy ones would have LCDs that flip up, but basically we'd have a VGA keyboard and monitor connected to each computer. Yeah. And that's just an inefficient way to run a data center. When you have 42, when you can now practically get 42 U's of storage, of CPUs into a rack, that you're not going to get 42 cables.
Now, that is a key technology and that is an advancement. It's by no means is it new, it's just newer. And there are other ones from other manufacturers which kind of sort of conflates the thing. And I bought a HP microPoliant a few years ago, and it actually turns out you've got to pay to access the out-of-band console, a license fee, which isn't great. But anyway, if you combine all of these booting services, like your DHCP, your NFS, your TFTP, your iPXE, you can get a workflow like I showed you on the Raspberry Pi. The challenge is, how do you make that secure for the enterprise? So secure for production, something that cloud native, that feels cloud native. I think one of the keys is it should feel like you have a pool of capacity that in theory could be infinite if you could add to it. And at any time, you can use it as if it was all homogeneous, right? Despite it being actually heterogeneous. We've got Raspberry Pi, Intel NUC, Dell servers, Ampere ARM servers, the whole works in there. But we want to treat it as a pool, right? And we want to be able to say, I've got this capacity, now I need a Spark server. Now I need a Kubernetes master. Now I want to run a GitLab CI runner, and to be able to request that by API or by some kind of workflow and have it declaratively brought into existence by the system. That's kind of how I see the cloud native approach on it.
Yeah, that makes perfect sense from a data center. As a data center provider, that has always been the nirvana, the end unit. Like, we tried to do this with virtual machines. Basically, the concept that, hey, you know what, we can deliver APIs to the hypervisor, from the hypervisor to my developers, and then they can provision machines. In practice, that just never got adopted, because managing virtual machines, this gets to your serverless concept. What developer wants to actually manage servers? None of them, it turns out. Containers and PaaS type solutions become much more digestible from a developer perspective. However, it puts stresses on the operators, and this is where we get into this developers versus operators model with the CNCF. It puts these stresses on the infrastructure folks that we just don't have the tools to give developers the type of control they want over the infrastructure, or this frictionless experience. This is, again, another promise to that mix of saying, hey, you know what? As an operator, I can manage and deliver an experience that developers are wanting to consume. I have, that I have a love-hate relationship with Kubernetes. I love that's the potential of the project. And when you layer something like OpenFaaS on top of it, it's wonderful. My problem is the merging of these two worlds. Oh my goodness, that's the difficulty.
I think, when you look at it, there's probably more levels to this than I imagined to begin with. There's a level of I'm an IT operator with deep knowledge into BareMetal and provisioning tools. How do I give my developers what they want today? The other side of it is how can we make our existing estate look and work like cloud? Developers want infrastructure as code. I've sort of highlighted digital rebar here. One of the things they're really keen on is infrastructure as code, right? IAC for short. This idea that you can use a tool like Terraform from HashiCorp to declaratively write, I want this server, this memory, install this application. You run a command and it gives you it. You then want a little bit more, or another server, you just add it in your file, you tweak a value, you run it again. And at any point, if you lost the servers, I don't know what happened, you had to switch to DR, you just run your script again, that's it. And at all times, there's no clicking in UIs, there's no sort of manual steps. We're not tied to a particular server. We just got this pull, and we've got this code in GitHub or in our GitLab, and we just run a command, we get back to where we were. Right? And so Digital Rebar is trying to do a little bit of that. You've got tools like Maz from Canonical that just sort of automate what's already there. Ironic, I've heard really good things about from the OpenStack Foundation, despite the
Mm-hmm.
OpenStack tooling sort of being sort of known now for being maybe a little bit overcomplicated, people saying that it failed for what it was designed for. Things like Ironic are sort of a phoenix from the ashes, where there's actual value there that you can bootstrap your cluster and then get Kubernetes on it and use your top level projects.
Ironic is still
A couple
super
more.
popular.
Yeah, a couple more there. Plunder is quite a fun sort of community project that one guy sort of scratching an itch in his spare time, Dan. But Tinkerbell was kind of, this one's caught my eye. This is from Packet. And I've been playing around with it. And what they're trying to do is sort of take their experience of the last 6 years of doing BareMetal by API and open source it. And it's anything but smooth. And there's a few teething problems, as to be expected, but it's a genuine, right? They do have the experience. They've done this stuff. And so I'm kind of very interested in that. I'm going to be speaking on it next week at Software Circus. And then other tools that are interesting are like MetalCase, MetalStack, MetalCubed. There seems to be a next wave of projects. So unlike these general purpose, the only goal is give me Kubernetes on BareMetal. That's it. I don't want VMware. I don't want a hypervisor. I don't want OpenStack. I've got these computers. I just want Kubernetes on it for the best possible experience.
Yeah, Alex, I really appreciate you coming on and sharing this practical experience. And for those people who are thinking, oh, okay, well, I have it now. I can go out and build a data center and provision this. There's still a lot more to do. Alex kind of hinted it to it, especially if you're focused on Kubernetes. Like there's real challenges because the infrastructure in most enterprises is either based off of iSCSI, Fiber Channel, or NFS. Obviously, how do you leverage that existing infrastructure to deliver permanent storage, persistent storage to Kubernetes? There's that challenge to overcome. And then how do you do it in a way that is friendly next to your Oracle and VMware workloads, et cetera? So taking this generalized work sets and applying it to a cloud native environment and delivery method, that's the work. And it's good work to do. I pick on Kubernetes a lot. It's not because I dislike Kubernetes. It's because right now we don't have the tooling and the skill sets in the open market to fulfill the dream. That I love sponsoring folks like Alex, and this is a plug to sponsor Alex over on GitHub. Right? What's your preferred?
There's a couple of things that people can participate in. One is if you've got a brand and you want to connect to the developers, get a link back from a high-ranking site. Come to openfaas.com, put up a homepage sponsorship. That's one thing. Definitely good for big brands. The second one is that there's an insiders program I'm running, and I'll send an email out with updates on all the open source software, but also on Kubernetes, on Raspberry Pi and Go, and do a little editorial. Last week was all about content marketing and what you would learn from that, how you can apply it even on an everyday job as an employee. Just go on there, see a tier that fits what you want. Feel free to sort of join in, and you'll get that premium newsletter. You also get to sort of contribute towards this open source software and the future of it.
Yeah, we have this saying in our community, different community, you either go or you pay to have someone go. So I prefer to pay to have Alex do the hard work of making Kubernetes consumable, and this is a great example of that work. Alex, thanks for the great work in the community. If you want to learn more about the CTO Advisor and what we're doing with the data center, you can go to thectoadvisor.com. We will launch a microsite, ctoadvisordc.com or CTOA.DC in the next couple of weeks, so you can learn much more about the data center. This content will probably be there. Until then, talk to you next CTO Dose.
Thanks, Keith. Thanks, everybody.